It aborted at 0, it got scrubbed by the weather, and then on the third try, it flew and came down in the Indian Ocean softer than it ever has before.
Starship's 13th test finally left the pad. That's our lead. Then, the strongest sign yet of a moon beyond our solar system. A robot mechanic heading for the graveyard belt of dead satellites. And what the far side of our own moon has been quietly recording about the Earth.
It's the weekend wrap. I'm Anna.
And I'm Avery. This is Astronomy Daily.
So we have been living with this one for weeks, and I want to give it the room it deserves, because the story of Flight 13 is really the story of persistence. Let's rewind for anyone just joining us. Back on the 16th of July, SpaceX counted all the way down to 0, and the rocket's own flight computer said no. 4 of the 33 Raptor engines on the booster didn't come up to healthy starting conditions, and the vehicle aborted itself on the pad. That's not a failure, by the way. That's the safety system doing exactly what it's built to do.
Right. An abort at T0 is the rocket protecting itself and the pad. Elon Musk said afterwards 2 Raptors would be pulled and replaced to be confident of a good flight. They swapped the engines, rolled back out, and then last week the weather turned. Thursday's attempt got scrubbed because SpaceX wanted clear skies. Not just for the launch, but to actually see the vehicle and photograph the heat shield under high stress on the way up.
And that brings us to Friday the 24th. Liftoff from Starbase in Texas just before 6:45 in the evening Eastern Time, so prime time viewing across North America, and the small hours of Saturday morning for us here in Australia. This was the second flight of the bigger, more powerful version 3 Starship. And this time, it went.
Let's walk the flights, because there's real nuance here. Not everything was perfect, and that's okay. First, the good news that matters most for the program, the heat shield. SpaceX and Musk both flagged a marked improvement in how the shield held up during re-entry. And that is the single hardest problem standing between Starship and genuine reusability. If you can't bring the ship home intact, none of the rest works.
The booster, super heavy, separated cleanly a few minutes in and flew itself back for a controlled splashdown in the Gulf of Mexico about 6 minutes after launch. But here's the honest wrinkle. On that final landing burn, it looked like only about 5 of the 13 planned engines lit. So it came down harder and faster than SpaceX wanted.
Now, important context so nobody mishears this. That booster was always going to be thrown away in the water. This wasn't a catch attempt. So a rough splashdown on an expendable booster is a data point, not a disaster. And crucially, it still made a controlled landing, which means they appear to have fixed whatever caused them to lose the booster outright on Flight 12 back in May. That one lost engines after separation and just fell into the Gulf. This one flew the profile. That's progress.
Then, the star of the show, the ship itself, Ship 40, sailed through its burn, coasted on a suborbital arc — this was never going all the way to orbit — and did something lovely on the way. It relit one of its Raptor engines in space. That in-space relight is a rehearsal for the maneuvers a future orbital Starship will need to come home. And then came the splashdown, west of Australia in the Indian Ocean.
And this is the bit I keep replaying. SpaceX's Dan Huot called it live, the softest splashdown they have ever had with Starship. For the first time, after the ship did its flip and settled onto the water and tipped over, it did not explode. It sat there, bobbing, still sending back telemetry and video, floating in the Indian Ocean.
Which, if you've watched these tests, is genuinely new. We are used to the fireball as the full stop at the end of the sentence. This time, the sentence just kept going.
There's one more first, and it's a big one for the Starlink side of the business. On the way up, the ship deployed 20 real Starlink V3 satellites, the first V3s ever to fly. Every previous flight that tested deployment used dummy mass simulators. These were the real thing. Big flat satellites with laser links and large solar arrays. And SpaceX says they successfully talked to all of them by radio and laser and pulled telemetry down.
Which 6 of those 20 carried cameras, specifically to scan Starship's own heat shield tiles and beam the pictures back. A clever way to inspect the shield in flight. The satellites then follow the ship's path back down, so they're not staying up there. It's a test deployment, not a constellation launch.
So how do we score Flight 13 overall? SpaceX and Musk both called it a success, and I think the fair read is a strong flight with one soft spot. The heat shield improved, the ship flew its whole profile and relit in space, the softest ever splashdown, first real V3 deployment, set against a booster landing burn that underperformed on an expendable stage.
And a lovely piece of timing to close on. The original launch date, the 16th, was the 57th anniversary of the Apollo 11 launch. Friday's launch date, the 24th of July, is the 57th anniversary of the day the Apollo 11 crew splashed back down on Earth in 1969. A splashdown anniversary for a rocket that's meant to help carry the next crew to the moon.
The road ahead is still steep. SpaceX has to dramatically raise the flight rate, prove they can catch the ship on the tower like they catch boosters, and crack an orbit refueling before Starship can land Artemis astronauts. But after weeks of near misses, Flight 13 is exactly the kind of day the program needed.
All right, let's move on to other news from the past week. In space.
From our own backyard to 70-odd light years away, and a discovery with a southern hemisphere finger point all over it. Astronomers using the European Southern Observatory's Very Large Telescope up in the Chilean desert have reported the strongest evidence yet for a moon outside our solar system. It's in a system called CD 352722, and it is, in the lead author's own words, super weird.
Weird how? Well, we've found more than 6,000 planets around other stars, but never once confirmed a moon out there. Every candidate so far has been contested. So what makes this one different?
This is the twist. It didn't turn up the way Exomoon hunters expected, a little moon crossing in front of a planet. Instead, the team, led by Kevin Hoy, an ESO student based in Chile with Alice Zerlo and colleagues, published in Nature, watched a brown dwarf and caught it wobbling. Something is tugging on it, and that something is a gas giant about the mass of Jupiter orbiting the brown dwarf.
So let me get the nesting doll right, because it's genuinely strange. There's a star, about half the mass of our own sun. Around it orbits a brown dwarf, bigger than a planet, too small to be a star, around 30 times the mass of Jupiter. And around the brown dwarf orbits this Jupiter mass object.
Exactly, and that's why nobody quite knows what to call it. It's the size of a planet, but it doesn't orbit a star. It orbits an object that orbits a star. So is it a moon? An exosatellite? The researchers themselves say there's no officially accepted definition of an exomoon, and this system blurs every line between star, planet, and moon.
And the honest headline, because this matters, is that the team calls it the first plausible detection of an exosatellite. Not confirmed, plausible, the strongest candidate we've had, but still one that needs more observations to nail down.
The technique is the exciting part for what comes next. They used radial velocity, the same wobble method that found the first exoplanet around a sun-like star back in the 90s, but applied it to a directly imaged brown dwarf for the first time, which means every one of those directly imaged giant worlds out there is now a fresh hunting ground for moons.
A new door opened from a telescope under the southern skies. We'll be watching CD 352722 closely.
Next up in our weekly roundup, Northrop Grumman MRV-MEP.
Here's a job title you don't hear every day: satellite mechanic. On Tuesday evening, a SpaceX Falcon 9 lifted off from Cape Canaveral carrying one of the more quietly futuristic missions of the year, Northrop Grumman's Mission Robotic Vehicle, plus 3 of what the company literally calls jetpacks.
I love this because it's so practical. We put enormous, expensive satellites up in geostationary orbit, the ring about 36,000 kilometers up, where a spacecraft hovers over the same spot on Earth. And historically, when one runs out of maneuvering fuel, that's the end of it. A perfectly good satellite, dead because the tank's empty.
So what does the mechanic do about it?
The Mission Robotic Vehicle, the MRV, carries 2 fully articulated robotic arms, each about 3 meters long, built by the U.S. Naval Research Laboratory under a DARPA program. Over the next year, it climbs out to geostationary orbit, and then it starts making house calls. It grabs one of those mission extension pods, the jetpacks, and bolts it onto an aging satellite. The pod becomes a satellite's new propulsion, buying it something like 6 extra years of life.
And then it moves on to the next customer. 1 robot, 3 pods, 3 rescued satellites. Here's the local hook. Among the named clients are SES in Luxembourg, and this one's for our Australian listeners, Optus. So there's a genuine chance an Aussie communications satellite gets a new lease on life from this robot.
This isn't coming out of nowhere either. Northrop's space logistics arm did this before with its mission extension vehicles. The first one, back in 2019, was the first commercial spacecraft ever to dock with a live satellite in geostationary orbit. But those were big one-to-one, one vehicle, one satellite for good.
Whereas the pods are smaller, cheaper, and reusable in the sense that the robot can keep deploying them. It turns satellite servicing from a one-off rescue into something closer to a routine, a tow truck service for the geostationary belt.
And in an era we're all worried about space junk, keeping working satellites working instead of abandoning them and launching replacements is a genuinely good news story about doing more with less up there.
Next, Chang'e-6 far side solar wind.
Our last highlight brings us home, to our own moon, and a result that turns lunar soil into a diary of the Earth. This is from China's Chang'e-6 mission, the one that pulled off the first ever sample return from the far side of the moon. The findings are published in Nature Geoscience.
And it starts with a question I'd never thought to ask. Does the solar wind hit the near side and the far side of the moon the same way?
Turns out, no. The solar wind is this constant stream of charged particles pouring off the sun. The moon has no real atmosphere and no global magnetic field, so those particles slam straight into the dust, and over billions of years, that dust, the regolith, becomes an archive, trapping noble gases: helium, neon, argon, krypton, xenon.
So the team compared the far side dirt that Chang'e-6 brought back from the South Pole Aitken Basin with the near side samples from the earlier Chang'e 5 mission, and the two sides tell different stories.
They do. The far side samples show the solar wind penetrating deeper and a distinctly different neon fingerprints. And the culprit they land on is us, the Earth. For part of every month, the moon's near side sits inside the Earth's magnetosphere, our planet's magnetic shield. And that shield actually slows the solar wind down before it reaches the near side.
The far side, meanwhile, spends more of its time fully exposed, taking the solar wind at full speed. Though the Earth has, in effect, been leaving its signature on one face of the moon and not the other for billions of years.
And that's the poetic bit. The far side of the moon, the side we never see from here, has been keeping a record of the Earth's own magnetic environment across deep time. To be fair, the scientists say the neon result is still a bit of a puzzle. More than one process is probably at play. But the headline stands. The moon's two faces have lived through different weather from the sun, and the Earth is part of the reason.
A little over 1.5 grams of far side dust, rewriting how we think about the sun-Earth-moon system. Not bad.
Finally today, our regular Skywatch for both hemispheres.
Well, that was the week that was, which means it's time to look up, wherever you are. Let's start with the moon itself, because it's the main character in the sky right now. We're heading toward a full moon, the buck moon, on the 29th. So tonight and over the weekend, you've got a big, bright, waxing gibbous moon lighting up the evening sky, north and south alike.
Which is beautiful to look at and a nuisance if you're chasing meteors, so let's set expectations honestly. The southern Delta Aquariids are active right now, and they peak on the 29th into the 30th. Southern Hemisphere friends, this shower is ours. The radiant near the star Scat in Aquarius rides high overhead for us, and it's also a fine show from the southern United States and the tropics.
But here's the catch this year. That peak lands right on the full buck moon, so the sky will be washed out at exactly the wrong moment. My advice, don't pin your hopes on peak night. Go out in the dark window before dawn, once the moon has set, and look well away from it. The Delta Aquariids are faint, so a truly dark patch of sky is everything. And a nice bonus. The slow, bright fireballs of the Alpha Capricornids are peaking around the same nights for both hemispheres.
And if the moon spoils this one, don't despair, because the big one is coming and the timing is perfect. The Perseids are already switching on, and they peak on the 12th into the 13th of August on a new moon. Dark skies, no interference. That's a northern hemisphere favorite. The radiant sits high in the north, but it carries down to the southern hemisphere's mid-latitudes too, so it's worth a look from northern Australia.
Mark that date because it's a genuine double feature. On the very same day as the Perseid peak, the 12th of August, there's a total solar eclipse.
There is. Totality carves a narrow path across Greenland, Iceland, and Spain. If you're lucky enough to be under it, that's the whole day sorted. Eclipse in the afternoon, meteors overnight. For most of North America and Western Europe, it's a partial eclipse rather than total, but still very much worth stepping out for.
And this is our non-negotiable reminder. Never look at even a partial eclipse without proper certified eye protection. Solar viewers that meet the ISO 12312-2 standard. Ordinary sunglasses will not protect your eyes. No exceptions.
Please take care of your eyes, safety first and all of that. As for planets, step out after sunset and brilliant Venus is climbing back into the western evening twilight. It only gets better through August. And if you're an early riser, the pre-dawn sky is where the action is. Saturn is well up in the hours before sunrise, with Jupiter returning low in the east. Southern Hemisphere viewers get these morning planets riding higher and steeper, one of the quiet perks of our southern skies.
So, a bright moon this weekend, patience on the meteors, and a spectacular double bill to circle for the 12th of August.
That's the weekend wrap. Starship's 13th finally flew and floated. The strongest hint yet of a moon around a distant brown dwarf, a robot mechanic on its way to the satellite graveyard, and the far side of our moon quietly keeping the Earth's diary.
Thanks for spending part of your weekend with us. You'll find every source in the show notes, and we're back tomorrow with your daily space and astronomy news. Until then, from Anna
and Ivory,
clear skies.
Astronomy.